This section explains the mixture of experts MoE model and code implementation. Let's first look at the MoE model overview. The mixture of experts is a neural network architecture that uses a set of expert networks to solve tasks, while a gating network determines which experts to use for each input. Instead of using all experts for every input, the MoE model uses a sparse subset of experts, usually a small number, to make predictions, improving efficiency and scalability. MoE can be divided into three main components. Expert networks. These are individual models, often simple neural networks like MLPs, that process the input. Gating network. This network decides which experts should process each input. Combination of outputs. The outputs of the selected experts are combined based on a weighted sum, where the weights are given by the gating network. The key idea is to leverage multiple experts, but only activate a small number of them at a time, thus making the model computationally efficient, while still benefiting from the diversity of expert models. Mathematical formulation of MoE. 1. Input X, the input vector to the model. 2. Expert networks. Let there be n expert networks, each of which maps the input X to an output yi for expert I as follows. Fi is the function, such as a neural network, of expert I, and yi is the output produced by expert I. 3. Gating network. The gating network computes a set of scores gi for each expert. These scores indicate how much attention each expert should receive for a given input X. Wi is the weight vector for expert I, and sigma is a sigmoid activation function, ensuring the scores lie between 0 and 1. 4. Top K selection. From the gating network, the top K experts are selected, meaning that only the experts with the highest gating scores will be active as follows. Gi are the corresponding gating scores. 5. Weighted sum of expert outputs. The final output y final of the MoE model is a weighted sum of the outputs from the top K experts as follows. Wik is the gating score for expert Ik, and Fik is the output of expert Ik. To ensure that the weights sum to 1, the gating scores for the selected experts are normalized. This normalization step ensures that the weighted sum is properly scaled. Finally, this process can be described as follows. Now we implement the MoE code. Expert module class. MoE gating class. Mixture of experts class. Testing the MoE model.